Hey everybody, today we're going to talk about fission and fusion, which is how nuclear reactors and nuclear weapons release energy. So first of all, what is nuclear fission? Fission is when the nucleus of an atom divides into two smaller nuclei. It is often paired with the release of energy in the form of neutrons and gamma rays. So in the picture here, the nuclei are these clumps, the red and gray things that I'm pointing at right here. So the neutron will come in and hit it and cause it to split into two smaller nuclei, which releases some energy in these neutrons and everything. So then you have all these extra neutrons floating around. But basically, short version is nuclear fission is splitting of atoms. Fusion is the other way around. Instead of splitting atoms, it's combining them. So in this picture here, this deuterium, this tritium, which we'll talk about later, are combining to make something bigger. So this thing, the alpha particle, you can see has 4 particles, and deuterium and tritium have 2 and 3. So the alpha particle is bigger than either of the things that came together. This is fusion. That's basically when 2 or more nuclei combine to form a larger nucleus. In other words, making bigger atoms from smaller atoms and just slamming them together. So using that information, which one of these reactions looks like a fission reaction and which one looks like a fusion reaction? In the top one, we have 2 atoms combining to make something bigger. Notice this 3 is bigger than either of these 2's, which means that the product is bigger than the things added together. So that has to be fusion. Whereas the bottom picture has this tiny neutron slamming into what is a uranium nucleus, then splits into 2 smaller nuclei. That's fission. You got those right. Good job. A chain reaction starts with this neutron right here on the left, and then it runs into this nucleus, which then splits, releasing more neutrons, which hit more atoms, which all split, releasing more neutrons, which split even more atoms, and this just keeps going and going and going. The proper definition is a chain reaction occurs when neutrons released in fission strike atoms around them and trigger additional fission elements or events in a continuous cycle. This basically keeps going until there's no more atoms to run into. So let's look at nuclear reactors and coal reactors. So the coal reactor is on the bottom. This is where coal is burned to give off heat, which boils water, which makes steams, which turns a turbine, which makes electricity. Basically like a generator, like we talked about in the electricity unit. Nuclear reactor does basically the same thing. It has a turbine and heat that heats up water to make steam, but where the heat comes from is from nuclear reactions using radioactive elements. So to put it in words, both create heat to boil water, generate steam to turn a turbine. This is the only difference. The only difference is how they get the heat. Whether you're burning fossil fuels like coal and oil and gas, or using the energy released from nuclear reactions. That's the only difference. There's some drawbacks to using fission for energy though. Well, the benefits, first of all, they don't release greenhouse gases like carbon dioxide. So they produce less things that affect global warming than burning coal or gas. And nuclear reactors also create radioactive isotopes that are used in science, medicine, and engineering. You may have heard of places like the proton therapy lab, where they actually use products from nuclear fission to help fight cancer, for instance. Drawbacks are that they generate a large amount of radioactive waste, which is really hard to deal with. I mean, we don't really have a good way, we just bury it. And they release radiation into the environment nearby, and the stuff that is in nuclear reactors is dangerous. It can be used to make bombs, which, I mean, rarely happens, but, you know, it's there. All right, so you're almost done. Thanks for watching and taking notes. Make sure to go into Schoology and answer the fission and fusion video questions to complete this assignment. Thanks for watching.